the community day. It would not have been possible without everyone who's been with us for the last 4 years. And most importantly, Mindcurv, who has been a continuous force of energy and support to AWS User Group Kochi from the get-go. And to provide a sponsor talk, we have Shanu and Melvin join us from Mindcurv. They'll be speaking about transforming resource management and maximizing cost efficiency with Karpenter. Shanu is an infrastructure developer at Mindcurv, part of the Accenture song now. Congratulations on that as well. Shanu is a seasoned expert in multi-cloud platforms with over 12 years of hands-on experience, specializing in containerization and automation. He's skilled in designing, deploying, and managing scalable infrastructure solutions. Shanu is a strong advocate for the 12-factor app methodology. Throughout his career, Shanu has successfully led Kubernetes migration projects and executed complex commerce tools implementations. He also serves as a mentor within the company, contributing to the advancement of solutions architecture. Accompanying him on this talk is Melvin Antony. Melvin is a cloud platform engineer at Mindcurv Group. He's a dedicated cloud platform engineer with a passion for building scalable, efficient, and reliable systems. Beyond his professional work, he actively maintains a home lab and explores advanced provisioning techniques using Docker and Kubernetes. As a community enthusiast, he enjoys sharing knowledge and engaging with peers through platforms like community talks, fostering collaboration and learning. His goal is to continue leveraging his skills to design impactful solutions while contributing to the growth of the tech community. With a loud round of applause, can we welcome Shanu and Melvin on stage, please? Hold on. Louder, let's go. Thank you.
Thank you, Ramesh.
Thank you. Hi, a very, very good morning. It's an absolute pleasure for us to be here at ACDKOCHI 2024. My name is Melvin Antony, and I am a cloud platform engineer at Mindcurv, which is now part of Accenture Song. A little about myself. Throughout my career, I have been fortunate to design and manage large-scale, secure, and cost-effective solutions along with AWS. My primary focus is on automation, scalability, and performance optimization, also driving organizations to a very more modern and cloud-adopted solutions. Also, as a personal note, I enjoy exploring home labbing and home automation, which also provided myself an opportunity to learn and deep dive into much more energy efficient and cost-effective IoT solutions. So before we dive into our journey with Karpenter, I will let my dear colleague here introduce himself.
Thank you, Melvin, and good morning, everyone. I wanted to say what a sunny day, but it's not sunny, so it's cloudy. So my name is Shanu Koyakutty. I'm an infrastructure developer at Mindcurv, part of Accenture. Like Ramesh mentioned, I'm mainly working across Kubernetes migration projects and implementing complex commerce tool solutions. But before we dive deeper into today's agenda, can you hear me all well? Yeah. So before we dive deeper into today's agenda, let me introduce you a bit about our company. Mindcurv, part of Accenture Song, is a leading expert in digital business transformation for customers with a special focus on composable commerce. Composable commerce is a modular approach to digital commerce, enabling companies to create and adapt their operations based on package business capabilities. This enables our organization, or the organization that we support, to rapidly evolve and scale their solutions, and helps in creating personalized and unique experiences for our customers. Yeah, sorry. So my plan was to use this thing, the one that comes with that. So yeah, that happens. So where were we? So yeah, today our agenda is to talk about Karpenter. So the initial plan was to talk about something else, but we wanted to do something basic. So Karpenter is an auto-scaling solution for Kubernetes. And we will discuss how Karpenter helped to transform the business capabilities for one of our clients, a major player in home appliance. But before we go deeper into that, I am sure we all have faced resource management issues and cost optimization problems in the past, right? So, yeah. So let's talk a bit about our journey, which my colleague Melvin will do.
Yeah, so managing resources efficiently is like trying to drive a car without its power steering capabilities. It's definitely possible, but it's very much complex and less efficient than it needs to be. So that was the situation that our client was in before we introduced them to Karpenter. Also, as a side note, we, Mindcurv, are an early adopters of Karpenter. So though our client is in home appliance industry, the lessons that we learned and the strategies that we employed are universal. So even if you are in e-commerce, marketing, or finance, the basic principles of having efficient resource management should remain the same. So I strongly encourage each one of you to analyze and think about the situations, problems, and solutions that we talk here and see if it's very much relatable and applicable to your own organization. So throughout our journey, we will quickly go through the business context, the solution that we tried out before Karpenter, and why we ended up with Karpenter, and some of the challenges that we had to face was going on with Karpenter. And finally, the main and highlight of this session, the outcome and impact that Karpenter made us. And finally, if the time permits, we can have a quick Q&A as well.
So let's dive deeper into today's agenda, or at least the first chapter of our journey, the challenges with traditional resource management. So we'll be approaching this in a problem solution manner, where we'll post the problems and the solutions as well. And the first problem that we faced while we using Karpenter, before introducing Karpenter, was with respect to running workloads on static nodes. So, yeah. So increasingly, we use EKS clusters for our day-to-day operations, where we handle millions of IoT devices that are spanned across the globe and different AWS regions. So basically, the backends for these IoT devices are in Kubernetes clusters, which span across different regions. So one of the challenge was that we had to scale these clusters upfront, and that too using static node groups. And this often led to over provisioning and increased costs. So, and the nodes, as I said, the nodes were underutilized most of the time, so this led to inefficiencies as well.
So the Karpenter's dynamic scaling capability came to the rescue here. Karpenter allows the cluster to scale up or down in real time based on the rapidly varying workload demands. So by automatically optimizing the workload efficiency, Karpenter eliminated the requirement of provisioning these static nodes upfront, thereby reducing the cost drastically.
Yeah, moving on to the next problem. So initially during our POCs, our plan was to use cluster autoscaler for this autoscaling solution, because it is the first thing that comes to our mind when we think about autoscaling. But cluster autoscaler often struggle with scaling speeds, often taking minutes to provision new nodes. And this was primarily due to the fact that cluster autoscaler had to communicate to AWS autoscaling rules to provision new nodes. And this provisioning time often included the delay in AWS to contact autoscaling groups to provision new EC2 instances, and for these EC2 instances to become ready and join the cluster. And again, with cluster autoscaler, we still had these issues with underutilized nodes, and this can be primarily attributed to the fact that cluster autoscaler works at node group levels, and this was something uncalled for. It was antithetical to what we were trying to achieve at the first place.
Yeah, so Karpenter tries to deal with this problem in a different manner rather than relying on the slow ASG mechanism. Karpenter directly talks with the AWS EC2 API. So this significantly reduces the latency, so significantly that Karpenter can spin up nodes even under a minute, which is kind of a huge deal compared to the traditional cluster autoscaler. Also, Karpenter provides an option for workload consolidation. In simple terms, it means Karpenter tries to consolidate all the workload across the across the nodes in the cluster and tries to squeeze it into minimum number of nodes. Also, keeping track of the cost because Karpenter is able to talk with the AWS cost API as well.
So moving to the next challenge. So we have implemented Karpenter. So everything went well. So that's the end of story. But unfortunately, that's not. So we had some post-implementation challenges as well. And the first challenge was with respect to misconfigured port disruption budgets, which often caused issues with scaling, mostly the scale-down operations. And during the initial stages of Karpenter, like my colleague mentioned, we were one of the early adopters of Karpenter. And during the initial stages of Karpenter, there were too much aggressive node consolidations, which often caused disruptions or at the least a degraded performance as well. Also, during the initial stages of Karpenter, there was aggressive rapid development that was happening in Karpenter, which often caused breaking changes, mainly for the custom resource definitions that Karpenter managed. This proved too much of an issue for us, so because since we were looking to reduce the management cost once we implemented Karpenter, and Karpenter didn't help in that at first, at least.
So we overcome the problem with the misconfigured PDBs by introducing a custom Kubernetes operator that's deployed across all the clusters across the globe. And this ensured that Karpenter can smoothly do the scale-down operations. Also, constant upgrades to Karpenter and careful configuration adjustments helped us stabilize the whole cluster across the globe.
So moving on to the next problem. So we have implemented Karpenter, everything is working well. And we had some outstanding issues as well before we implemented Karpenter, and we were trying to solve that using Karpenter as well. So one of those outstanding issues was with respect to GitLab runner performance. So increasingly we use GitLab, the in-house GitLab and the GitLab runners for our build and deploy stages. And we oftentimes required pipelines that required performance storage for high-speed pipelines. And one of those challenges was to isolate these workloads. And here also Karpenter came to our rescue.
So to tackle this, we had to create a dedicated node pool in Karpenter. And this node pool is configured with instance types that comes with NVMe instance store. And these nodes were completely isolated with the general workload by making use of taints and tolerations in Kubernetes, thereby completely allocating GitLab runner ports just for the new and faster node types.
Finally, about the outcome and the impact that we have observed after we implemented Karpenter. With Karpenter, it helped with better workload consolidation, better resource handling, cost optimization, and whatnot. So it was like a panacea for all our problems. So let's discuss a bit about the scaling profile as well after we implemented Karpenter. I have here plotted two graphs. The first one is the total CPU utilization across all the ports for the entire production cluster that we had for one of our regions. And the next one, the second slide, is about the number of nodes that was scaled up and scaled down at that same time, or at least around the same time. All thanks to Karpenter. So as you can see, the workload, the utilization is quite varying. Peaks in demand, and at times once the peak subsided, the CPU utilization went down as well. As you can see from the second graph, it almost follows a similar pattern, and that was all thanks to Karpenter. It helped in quick scaling, and once the demand subsided, Karpenter helped in scaling down the nodes to the bare minimum. That was it. We will also talk a bit about the cost savings part as well.
Yeah, here comes the main part. So, so the cost savings were remarkable, like I hinted before. You can see a 60% of decrease in just EC2 spends per month. So this itself can scream the effectiveness of Karpenter in managing the resources efficiently.
Yeah, to summarize, with Karpenter we had better scaling, better cost reduction, and better workload consolidation. Yeah, and that's all for today. We thank you for your time to explain to you our journey. And in the next slide, we do have a small QR code. We have explained to you the implementation details of Karpenter, what issues that we faced before Karpenter, the challenges that we faced before and after Karpenter. So we have written this small article with the help of AWS technical advisors. Maybe I can show the slide for some time, right? And if you have any questions, maybe we can answer it in the booth. We have our booth just behind that door. You can, or if you have time.
If anybody has any questions for Shanu and Melvin.
Mm-hmm. Yeah, that's what you meant. So our workload is particularly quickly varying, and we expect huge hikes in traffic. So cluster autoscaler is a bit slower to scale up. So that's where Karpenter comes in, because it talks directly with the EC2 API. Yeah, at the moment, Karpenter is out of the box supports only AWS, but in the roadmap, it supports, I think, other cloud.
It supports Azure as well, but there is a plan to implement the same in GCP as well. There is an ongoing issue that I can see. But like I mentioned, cluster autoscaler had to communicate to autoscaling groups to scale up the nodes. On the other hand, Karpenter, what it does is it directly communicates to AWS EC2 APIs. Basically, it calls an EC2 fleet operation, API operation, and that helps in quick scaling as well. Okay, and thank you again for your time.
No, there's one more question.
Okay.
Yeah. So basically, you told that you are basically working on the e-commerce industry, right? So basically, for e-commerce industry, there will be obviously sales during year-end sales, or maybe during festival seasons, there will be sales, right? So on that situation, there will be obviously increase in the load.
Yeah.
So do we need to do any special kind of configuration in Karpenter level to enable that scale up, or it will scale up automatically?
No, it out of the box supports everything. Yeah.
Okay. Thank you.
Yeah, thank you once again. And I expect everyone to visit our booth. It's just around the corner.
Thank you so much, Shanu and Melvin. Can we have a loud round of applause for Shanu and Melvin?